Greetings everyone, this is Non-Expert here, and today we are going to be talking about the Singleton design pattern. The Singleton pattern comes under the creational pattern classification as it also deals with some sort of object creation mechanism. The reason why it's called a Singleton pattern is because it lets you, as a developer, ensure that a class has only one single instance, while providing a global access point to this instance. What that basically means is that in your code base, no matter how many multiple instances you try to create of a singleton class, there's always only going to be one. Implementation wise, it sort of depends on the programming language that you're using, but there are always two common steps which are followed. First, you want to make sure that there's only one instance getting created, and this can be achieved by overriding the default behavior. So if you're using something like, say, Java, this can be achieved by creating the default constructor as private, or if you're using something like Python, this can be achieved by overriding the init constructor method. The second step is you want to create a static creation method that acts as a constructor. Under the hood, the way it would work is that whenever this method is invoked, it would create an object and save it in a static field, essentially just caching it out. Therefore, for all following subsequent calls to this method, it will just return the same cached object. There are several applications to using a singleton pattern. So let's say if you're trying to create a logging module, you might consider creating it as a singleton class, as for each instance that you create, you would not want to have separate connections to your same log file that you're saving into. Now let's take a moment to see how you would go about implementing a singleton class in Python. Now to be very honest with you, it sort of depends on how you want to go about it, but the way I like to create a singleton class is as follows. I start by creating a class, and just for the purposes of this demo, I'm just going to call it Singleton. And for the next step, what I'm going to do is I'm going to create a class variable. And I'm just going to call it as instance. If you're not familiar with what a class variable is, that's completely all right. It's basically a variable that's shared by all instances of a class. Class variables are defined within a class, but outside any of the class methods. I also want to make sure that this class variable is private. And there's no such concept as writing a private in Python. But the way you want to go about privatizing your variables is by adding double underscores. What I basically would tell your interpreter to do is basically hash it out so it's not accessible easily from outside. The next step is you want to override the similar init method which we have. So no matter which all arguments that you're passing in, it won't matter because you will just return nothing. But a better operation over here would just be to raise an exception instead. So we can just raise an exception over here. So whenever somebody just tries to create an instance of the singleton class in the default way, we will just raise an exception stating that this is a singleton class. Now, the next step over here is the second step that we talked about, which is creating a static method. And the way to do that is by using a static method decorator in Python. Now, I'm just going to call a function, define a function. I'm just going to call it getInstance. And essentially what this function is going to do is that whenever this function is invoked, we're just going to use the instance variable and just update that. So the way to go about using the class variable is pretty straightforward. We use the singleton class and we just call .instance. And what we're going to say for this function is that if this instance has not been updated so far, we'll go ahead and update it. Basically just incrementing the value would suffice for now. And otherwise, what we want to do is we just want to just return that instance variable. So essentially, whenever somebody tries to call the getInstance method, what's going to happen in the background is that it's going to check if this instance has been updated from 0, which means that has it been called before. If it's been called before, it's just going to return the same value. Otherwise, it's just going to update the value and just go from there. So let's try to check how we can test this entire thing out. So let's start by just creating a simple object and let's just call it Singleton. Now do note over here that this should basically send an exception our way, because in the init method, you cannot just call it in the normal behavior way. So let's just first execute this cell and just try to call this. And you can see that's throwing the same Singleton class exception that we defined before. Essentially, we also want to check that can we just access the instance normally? And if we try to do a print and just call singleton.instance, we should also get an error stating that this is not available. The reason for that is because we privatized it, as mentioned before. Now let's create two objects the right way. So we can say singleton.getInstance, and do note over here that since we called it as a static method, we don't really need to call this. In order for us to call this function, we don't need an instance, we just need the class, and that's it. So let's just create another variable. We're just going to call it object2 and just call getInstance. So if you want to test this out, it's going to be pretty straightforward, but to test it out, let's just start by checking if the values of object1 and object2 are the same. And in our case, it should be the same as it should be 1. So if we print it out, we can see it's 1, 1. However, there are better ways of actually testing this out. Another way is by actually just looking at the memory address. So if we look at the memory address of obj1 and obj2, what we should see is that it should point to the same memory address. So if we run this, we can see this point, which is exactly the same. The other methods of actually testing it out, and the way I would actually test it out in a more Pythonic way, is by using the assert statement. Just by saying if the obj1 is actually equal to obj2, we use the assert for obj1 is obj2. Now the equal to operation would just check the value, but the is value would actually check if they're pointing to the same reference. And since we did not get any error, that would basically help us say that this particular object is pointing to the same particular value that we talked about. So essentially what we've done is we've created a singleton class, which no matter how many instances you try to create, it's always going to point to the same value. Now let's take a moment to look at what are the advantages of actually using a singleton pattern. Well, apart from the obvious, there's also initializations. So for each object created by a singleton method, there's always going to be, it's going to be only requested when we call it for the first time, and that's basically it. Then there's also access to the object. We got the global access to the instance of the object as we talked about before. And the count of instances which we are basically maintaining over here would never be updated because it would always be one instance at a time. Therefore, you're also saving a little bit on memory. Now, I've also want to mention that there are a few cons of using a singleton pattern, which are it's a little difficult to perform unit testing while using a singleton pattern, and you have to perform some mock operations in order for you to do so. There's also problems with thread exceptions, but the way Python sort of already handles threads using GIL is sort of allows us to take care of that automatically. And with that, we end this video. If you did like this video, do leave a like, and if you didn't really understand something, do leave it in the comment section below, and do consider subscribing to our channel. And if you've already subscribed, you're awesome, we all know it, and have an awesome day. Thank you.